Yeah, microphone on. So that should be working now, right? You know those awkward starts to videos? I have one like every single video I do, I swear. Okay, what is the remainder? There is like a remainder theorem that you can actually do. And I'm not gonna lie, I can't remember how to do it right now. So we're just gonna do the long division because the long division question might pop up on there. So we're just gonna do this the long way. Okay, so I'm gonna rewrite this. And we're gonna zoom in, maybe. Here we go. So we got this is going to be going into here. We got 2x to the fourth, 3x to the third, minus 3x squared, minus 32x plus 87. Okay. If you don't have access to this on the Chromebook quite yet, make sure you're writing it down with me. Okay, so what we're asking ourselves is what do I need to times this x by to get it to be 2x to the fourth? Yeah, so it's going to be 2x to the third. So that's going to give me a 2x to the fourth. Then I need to take that and I need to multiply it by the 1. So now we have 2x to the third. And then we're going to change the sign on each one. And what that does is it allows us to minus that out and get rid of the first one. So now we got 3x to the third minus 2x to the third is going to give me an x to the third. Then I need to bring this one down. So that's a negative 3x squared. And now I'm going to redivide out, right?
So it's going to be just x squared.
Yeah, so this next one is just going to be x squared, and it is a positive x squared. And then I'm going to multiply through. So that's going to give me x to the third and then an x squared. Then once again, I change signs so I can cancel those ones out. And that's going to give me a negative 4x squared. I'm going to bring the next one down, minus 32x.
So it would be minus 4x.
Yeah, so it's going to be a negative 4x here.
And then you switch this.
Because that gives me a negative 4x squared and a minus 4x. And then I change the signs. So this, yep. And the reason why I do that is I want to be able to cancel out this first term. And if I have a negative, I need it to be a positive. Okay, and then I got negative 32 plus 4. That's going to give me a negative 28x. And I'm going to bring down my 87. Okay, and now I'm going to divide out again. So what I need to times? This is going to be a minus 28. So that's going to give me a minus 28x. And then minus 28 here. Those go away. Need to change this sign. Let's see. 80 it's 115. So we're done here. We can't divide anymore. So that's my remainder is 115.
So when it doesn't have to remainder, you solve it, don't you put it over? Did you just say that?
Yeah, you put it over x plus 1.
Put it over x plus 1? Oh, yeah, you're right.
You do that in this one, or?
I have the answers down below, so that should work out. So this is what? Just question 2. Wow, we're making great strides. Oh, it just says 115.
So when do you put it over x plus 1 when it's asking for the whole answer and you have you write?
I think so. Yeah, I think if it's asking for the whole answer, then that is a term. It's 115 over x plus 1, but the remainder is just 115.
So like if it just says solve, you would put the 115 over x plus 1.
Yeah.
Okay.
So I think there's an easier way to find just the remainder, and I'd have to play with the calculator. Should we do this real fast? Oh, we got such short time. I think if you plug in a negative 1, so it's the opposite of what you have here, and you plug it in for x, I think you'll get 115. Here, somebody has that written down, right? Okay, so we go. Here's Desmos. what is it, 2x to the fourth? Okay, so we got 2, whoops, come on, keep up with me. Keep up with me. Why is it not working? It's working here. Hey, you get 115. So it's called the remainder theorem. You're changing it, and if you have a coefficient of like, if it's like 2x plus 1, you can't do it. Does that make sense?
Yeah. So
It has to be like an x to the first.
So if it was like x plus 4, you just put in -4.
Yeah. Yep.
Oh, that's nice.
Okay. All right. LCD. Woo. Least common denominator, right?
Man, this stuff sucks.
But it's stuff that you can do. So what we're going to do is we're going to factor each one of these. So I got a -8 and a -7. And that's going to give me a -8 and a +1. So this right here I could rewrite as c minus 8 and then c plus 1. Over here I've got a 4 and a 5. So that's a 4 and a 1. So that's c plus 4, c plus 1. And so all we're doing is once we get those, I honestly don't care what's on top, but we just want to have all of our, so we have like a c plus 8, and the only one really you have duplicated is a c plus 1, but we just want to make sure we have all 3 of the different factors there. Yep. So we're just, our answer is going to look something like c minus 8, c plus 1, and then c plus 4.
What's going on? I'm not gonna get sick again.
Okay. It's asking us to simplify. So first thing we need to do is we need to get the denominators to be the same. And what would we need to times one of the denominators by to get it to be the same as the other denominator?
-1.
Which one are we going to times by -1?
The x minus 7. Or either.
Negative x plus
Does it matter?
Which one would you want to do?
negative x plus
Alright.
I would do the one on the right personally. Okay? I would times this by -1 over a -1. And the reason why is it gets rid of the negatives on the other side. I mean, if we can get rid of some negatives, it does add some. So then we're going to have the 6x squared minus 46x plus 35. And then we've got a minus 2x and a plus 7. And all of that is over x minus 7 because we distributed here.
So then
So now we're going to combine like terms. So we still have 6x squared minus 48x plus 42. Okay, we need to check to see if there's something we can factor here. I don't know if there is or not. I know I can factor out a 6. So we got x squared minus 8x plus 7. We have this x minus 7. So now we're going to have to do the x method. So we got 7 and -8. So -7, -1. So we got 6 and then x minus 7, x minus 1. And then that is over x minus 7. Hey, is there something we can cancel out? We can get rid of the x minus 7. So that's going to leave us with 6 and then x minus 1. And then, I mean, it could be 6x minus 6. Let's see what type of answer they wrote here. What question was this one? Just 3? Oh, man, we need to fly. Oh. So they distributed the 6. But if you do this one and you don't distribute it and it marks it wrong, I'll mark it right because that's. This is the same. This is the one I just did.
Because they put the. I always write like 6, but it's the x.
Yeah. So I think on Alex or on Newton. Sorry, I call it Alex all the time. I think either one of those answers is fine because they are equivalent. And they are. I mean, they're simplified. One's distributed. One's factored. I'd be happy with either or.
Have it down on your paper if it marks it wrong.
Well, no, and you would enter in one of these, I would know, right? So if it's right, if I can distribute and I can get the same answer, I'm okay with that. Okay.
This one where you times it, it'd be like the left side you times, or no. Wait, you just times the left side by x minus 3.
Well, we need to get x by itself, right? So this one isn't necessarily to make the denominators the same.
Oh.
We just need to get x by itself. So on this one, in order to get rid of this denominator, I got to go x minus 6, right? And that gets rid of there. But if I do it on one side, I got to do it on the other side. So let's rewrite what we've got. We got negative 3x plus 18 over x minus 2. And that's equal to 5 now. So now I'm going to go x minus 2, x minus 2. So I can get rid of those. So I got negative 3x minus 18. Whoa.
I remember this stuff. It's not that bad.
Equals 5x minus 10. Now we combine like terms. Plus 3x plus 3x plus 10 plus 10. So those go away. Those go away. We have negative 8 equals 8x. Divide by 8. Divide by 8. X equals negative 1. Okay, what would happen if we did this and I got an x equals 2? Would that work? Like right now, if I plug in a negative 1, that's fine. I don't get any issues. But what would happen if I got an x equals 2 or an x equals 6? What do we call that?
Undefined.
It would make it undefined. I think our answer would be called extraneous solution, right? So sometimes when we get two answers, we need to be able to go back and plug it in to make sure that we're not getting any domain errors, any undefined answers. Okay? And if that's the case, then it's just not part of the answer set. Okay, how would you guys go about this one?
Flip, like,
I would
rewrite dot flip.
I would copy dot flip immediately.
Yeah.
Okay, so I got 4. Should we factor it right now too? Might as well, because we're going to have to, right? So that's a negative 1. So I got negative 2 and 1. So I got c minus 2, c plus 1. And we're going to be timesing it by c plus 1 over 2. Okay, what can I cancel out? Reduce out. C plus 1. 4. Yeah, I could rewrite the 2. 1 second.
As a 2 on top.
Yeah, I could write this as 2 times 2. So that allows me to get rid of these ones. So I got a 2 on top with a c minus 2 on bottom. Yeah, that was not too bad. Not too scary, yeah? Copy dot flip. I'm going to rewatch this and just be so embarrassed. You guys ever do that?
Can they hear us?
Well, if it picks up on the mic on the iPad.
Who's going to listen to it?
I'm just giving it to you guys.
Oh, nice.
Yeah, I don't like recording myself.
No, it's awful.
Yeah.
Sounds normal to
Okay, what do we do? I think this one's one of the easier ones, so let's just go through it fast. You want to get x by itself and in the middle. And luckily, these negative 8x's, if I add 8x here, these go away. Honestly, I don't know what I would do if these didn't go away. So I got negative 12 is less than 3x minus 9 is less than 6. And then I'm going to add 9, add 9, add 9. So we got 3 is less than 3x, which is less than 15. And divide everything by 3. It's going to give me 1 is less than x, which is less than 5. And it says write it in interval notation. So this is not a final answer. I have to write this in interval notation. What is interval notation?
So you have like the parentheses.
Yeah, it's the parentheses or the brackets. Okay, are we using parentheses or brackets in this one, first of all? We're using parentheses because they're both less than signs. They don't have the greater than part or the equal to part. Okay, so I do have, and so remember, it's everything from 1 all the way to 5. That's what that means. It could be 1, it could be 2, it could be 3, it could be 4. Well, it can't be 1 or 5, but up to, right? It could be everything in between, and that's how interval notation works.
So if one of the signs flips, wouldn't you have to do 2 sets of parentheses, right?
If you have x's on the outside.
Well, what if like the sign shows x is greater than 5? Wouldn't you have to do 2 separate parentheses?
Yeah, you'd have to put the union.
Yeah, so wouldn't it just be like 1, comma, what did it put? Like how, is it?
I'd have to see one to play around with it.
Okay.
But you want to cover all your bases, right?
Yeah.
So you just kind of got to look at it and interpret what's going on and then make a decision. Okay. All right, we did a few like this. We did some more. We did some like this already. Okay, simplify. Woo! This is a good one. What can I divide out of this top one?
Can you divide 7?
7 doesn't go into 54. I think I can divide a 6.
Yeah, that's it.
Somebody want to do 132 divided by 6 for me?
It's 22.
It is 22. Okay, so I'm going to go 6. That's going to give me a 9n squared plus 7n minus 22. And then I'm going to pull out a negative 5. Why am I pulling out a negative 5 instead of just a 5?
So our first.
Our leading coefficient needs to be positive. Okay? So that leaves me with 9n plus 2n. Oh, no. Minus 2n. And then minus 11. Does that look right?
Is that your final answer?
No.
Oh, you're gonna accept it now.
Yeah, we got to do x method on both of these. Okay, 9 times 22. 99, 198.
Those are big numbers.
Okay, and then this bottom one, we got negative 99 and a negative 2. Okay, 7, let's see, let's do 14. Hey, I need somebody with a calculator. Come out here. So, for the video here, I'm doing 198. I'm going to divide it by 14. Nope, that doesn't work. Let's divide it by 16. Nope. Let's go divided by 12. Nope. Is it divisible by 8? It's divisible by 9. Well, we just did that. 9 and 22, we need a difference of 7. Let's try 12. Nope. 11. It's divisible by 11. Hey, there we go. So we got 11 and 18 have a difference of 7, so it's a negative 11. So we got 6. Oh, come on, don't do this to me now. And then we got n minus 11, and then n plus 18. And I hope one of these needs to be probably 11. Oh, yeah, it's 11 and 9. Yeah. And that's a negative, so I got minus 11. Whoa. Okay, so now I can cancel this out. This reduces, so I got 6 and plus 18 over negative 5 and plus 9. And that's fully simplified. I am not fully simplified. Thank you. Yeah, I do have to divide by my A value. So I was just corrected, and absolutely so. So let's try this again. So I got n minus 11, and then I got to divide by 9, n plus 18, divide by 9. So I've got 9n minus 11. That's with the 6. And then n plus 2. Okay, then with this one down here, I've got 9 minus 11, 9n minus. Guys, I'm trying to go too fast and I'm making mistakes. So make sure you just slow down, right? So I got negative 5 and then 9n minus 11. And then n plus 9 divided by 9, n plus 1. There we go. I think I probably could have done it afterwards, but this is better practice. There you go. Thank you. Appreciate that. There's nothing worse than watching a math video online and you notice a mistake and then they don't go back and fix it. Like there's this guy I watch that helped me through a lot of my masters, and he's awesome. But he had this one video, and I really needed to know what he was talking about, and he messed up, and it made me cringe. It's way better than I'll ever do. But okay, do I already have the same denominator? Yeah, so I don't need to really change anything here. This is going to be a negative 10, so I got 3c squared plus 13c minus 10 over 3c minus 2. We will want to do the x method. So I got negative 30 and 13. So that gives me a 15 and negative 2. This time I'll divide by 3. So divide by 3, divide by 3. So that's going to give me a c plus 5. And then a 3c minus 2. And that's over 3c minus 2. 3c minus 2's go away. C plus 5 is our answer. Ooh, I like this one. This next one's a good one. Okay, what is this?
Squares on top, or the cube on top, or
Sum of cubes on top,
and then difference of cubes on bottom.
difference of squares on bottom. Okay, so remember we follow a specific pattern. Okay, so we've got the cube root of 125 is 5, so we got 5x plus 3. And then it's going to be a minus, then a plus. Oh, didn't give myself enough room. And then, so that's going to be 25x squared. I'm going to multiply them together. So it's going to give me 15x. And then that's a 9 because it's the other one. And then here I've got 5x plus 3, 5x minus 3. And then those are going to go away. And this is our answer here. Okay, that's not too bad. We've done a lot of those. That's not too, we can do that. So where is this undefined? What do I got to do? Set the denominator to 0. So I got 10d plus 5 equals 0. And then we got 10d equals negative 5. Divide by 10, divide by 10. D equals negative. Man, you guys watching this video, zooming in and out. Hopefully you don't get seasick. Thinking about that. Sorry. Domain and range, we've done that one. We're just evaluating, so this is just substituting. Wherever I see a U, I'm plugging in a 2. Wherever I see a V, it's a negative 2. Remember, use your parentheses. Go slow. You should be able to plug this one in fairly quickly. Okay. All right, this will be a good one. I need a common denominator. So how do I turn a 20 and an 18 into the same number? If we times it by 5, we'll get, let's see, what's 18 times 5? That's 190. So that doesn't work. Maybe we'll have to just times it by 10. So we get 180. I think that's what we got to times it by. If we don't know what to times by, we could always just times by 20 and 18. There might be a little bit more simplifying. I'm going to times this by 10 because that's going to give me a 180. And then I have a p to the 6th on the left and a p to the 3rd. So I do have to times this one by a p to the 3rd to get it to be 6. And then I do have to times the other one by q. And remember, I got to do the same to the top and the bottom. Okay, and then this one, so that's going to give me 80 p to the 3rd q over 180 p to the 6th q to the 5th. This is a plus. So what do I need to times 20 by to get it to be 180? It's just 9. I think that's all we're doing. So I got 18 over 180 p to the 6th q to the 5th. Now I can combine the numerators. I got 80 p to the 3rd q.
I've done either refresher questions.
It's probably a number before. We might be able to simplify a little bit. We got a plus 18. 180 p to the 6th q to the 5th. I can factor out a 9. I can't factor out a 9. I can factor out a 2. I could have done this by 5. I couldn't have. Factor out a 2. It's going to give me 40 p to the 3rd q plus 18 over 180 p to the 6th q to the 5th. And then I can simplify. So I got 40 p to the 3rd q. Oh, this is plus 9. Plus 9 over 90 p to the 6th q to the 5th. All right, that's my answer. Should we go see if it's right? Question 18. Hey, look at that. I did it. Okay, how would we go about doing this one? We kind of did one similar to it already. We need to get rid of our denominators. And if I times this by just 8x, if I times everything by 8x, so those ones will go away. That goes away. This is 4 times 2. So the 4 goes away. What's up, Kimmy?
Hey.
So I got a negative 10 and then minus 32x equals a negative 9. Plus 10, negative 32x equals 1. Divide by negative 32. X equals negative 1 over 32. Just 19. Cool.
Was this test the same amount of questions as the last one?
I'd have to look. I think it's a little shorter. The other one was like 43. That was a 35.
The other was ruthless. What is that?
This is not as scary as it looks.
Multiply and make it.
You just simplify it.
So what are we going to do with that last one?
Flip it.
We're literally just flipping it. Okay? We do want to factor as we go. So let's start doing that. So I can factor out a 4W. So that's going to leave me with a W minus 3. And then here on the bottom, I can factor out a 2, so I'm going to go W minus 1. We do have to do the X method here. So negative 4 and 3. So 4 and negative 1. I'm going to times. So I got W plus 4. W minus 1. All over. This is a difference of squares. So I got W minus 1. Or 2. Sorry. And then W plus 2. And then I'm flipping this one over. So I got 2 W minus 2. And then I'm going to factor a 4W out of this one. And then I've got a W plus 1. Okay, this is honestly my favorite thing to do in math.
Get rid of those things.
I love getting rid of things. Okay, so I got a 4W and a 4W.
Yep.
I've got a 2 and a 2. I got a W minus 1, W minus 1. I got a W minus 2, W minus 2. And I think that's it. So we've got a W minus 3, W plus 4 over W plus 2, W plus 1. Was it too scary?
No.
No, I love that type of question. We do have to factor as we go, right? But, yeah, that's not bad at all. It looks really scary, but it's... That's the type of question I love, because you get to cancel a bunch of crap out. Choose all expressions that are equivalent. Okay, this is one where we got to be careful with distribution. Holy cow. So, what I would suggest, let's go through, and so this A, if I times it by negative 1 over negative 1, that would change all of my signs. So I would say that A is equivalent. Okay? The second one, I would reorder it first. So I got negative and then negative 3x plus 7 over x plus 6. And so that would make this one a positive, this one a negative.
But then you denominate.
Well, it's really just you're distributing a negative 1. So it's like negative 1 over 1. So I say that one's probably the same too, actually. Because you're not timesing it by negative 1 over negative 1. You're timesing it by negative 1. So that's the negative 1 over 1. So you're just distributing. I would say it's B. Okay, let's rewrite this one again. I got 3x minus 7 over negative 1x plus 6. So that's not the same. This one would be negative 3x plus 7 over x plus 6. So that's taking out a negative 1, so this is not either. Question 21. Those are the two that I chose, right? Nope. I chose B.
A and B.
Did they reorder the questions, though? Sometimes they do the...
Yeah, you're right.
I think I'm right. It doesn't, yeah, that didn't line up, but I noticed that in the first test that they don't put the answers in the same order as what it gave it to you, but it still is right.
Why do they do that,
I don't know. But it's not necessary. It's connecting it with the right one. Like they're correct, but it's kind of annoying. Okay, which ones can be simplified? This is going through and just factoring each one, seeing if there's anything you can simplify out, can reduce.
What is this?
So I think this one's fairly straightforward. I want to find some more that are different. Absolute values. What do you guys remember about absolute values? Should we just do this one real quick? Let's do this one real quick. Okay, what do I do when I get to this point? I got an x minus 2 equals 1, and then I got an x minus 2 equals negative 1 as I write it to. Okay, I'll add 2, add 2, add 2, add 2. So I got x equals 3, x equals 1. I'm guessing you're just going to write them as separated with a comma, so 3, comma 1. All right, this is where we get into the fun part.
Oh, I hate those.
Okay, what do we do? Do we need common denominators?
Yeah.
Okay, so what am I going to times this right-hand side by?
X minus 7 or X minus 8. No, it's 8.
And I'm going to do the same thing down here on the bottom, right? Okay, so I'm going to get x minus 7. And then this is a negative 2. So I'm going to distribute that in right now. So I've got, okay, x minus 7. And all of this is going to be over x minus 6, x minus 7. So I've got negative 2 times x, which is going to give me a negative 2x. And then negative 2 times negative 6 is a plus 12. And all that is going to be over 2x minus 14. Then a negative 5 times x, so that's a negative 5x plus 30 over x minus 6, x minus 7. So let's combine like terms and copy dot flip kind of in the same go. So this top one, I've got negative x plus 5 over x minus 6, x minus 7. And then I'm timesing by x minus 6, x minus 7, which is convenient. And then what do I have as my denominator? Negative 3x plus 16. So these whole things go away. So we've just got the negative x plus 5 over negative 3x plus 16. Okay, when I simplify this, what's going to be the first step to make this a little bit easier? Should I reorder these? Can I do that?
Yeah.
Yeah, I can use the cumulative property, right? So I've got 10z plus 80 over negative 3z plus 24. That just gets it in the same way so we can kind of just see what we need to get rid of. I'm going to pull out a 10. It's going to give me z plus 8. So ideally, I'd want a z plus 8 on the bottom as well, right? Is that going to be possible? If I just factor out a negative 3, then it allows me to reduce these because they go away. I'm just left with 10 over negative 3, or negative 10 over 3, or negative 10 over 3. Those are all equivalent. Woo! Okay, it's another solving. So what do we want to do? We having the same conversation? No.
But I don't have it.
What do you do?
Times by x plus 8 and x plus 10.
Is that what we're going to get? Is that our factored thing over here?
That's the factor thing.
Yeah, this is 8,
And that is
18, 10,
48. So 3x
8.
plus 6, so 3x squared plus whatever.
Okay. So we're going to go x plus 8, x plus 8, and x plus 8, right? And that cancels those ones out, but then we need to do x plus 10, x plus 10, x plus 10. So what that does is these go away, and all these go away, right? So that's going to leave me with 3x squared plus 30x plus 6x plus 48 equals 48. How are we feeling about that so far? Okay. In your head, what do you want to do right now? Should we combine like terms? So we got 3x squared plus 36x. And then we minus 48. That's going to get rid of both of these. So this whole thing equals 0. And then let's factor. What can we factor out? So let's leave me with x plus 12 equals 0. And then what do I do now? Set each term equal to 0. Set each factor. Okay, we do need to check to make sure that these solutions will not make my solution extraneous. What would be the solutions that I could possibly get that would make that solution an extraneous solution? Like what number would I plug in that would give me a domain error? A negative 8 and a what? Negative 10. So if I got either one of those answers,
You just don't put them.
I just don't put it. Yeah, but I didn't. So this one has 2 answers. Okay, so we need a factor, and we need to times each side by the factor that they don't have in common, right? Lots of factoring. Said it wasn't going to go away, am I right? What's this? Just 9 and 4 again, right? And then I'm going to divide by the 4, divide by the 4. So this one's going to be 4c plus 9. And then c plus 1. And factor here, got, I don't know, 4 times 54 is going to be what, 216? Somebody want to do that one for me? I think it's 216. And my guess is one of them is going to be 9. What's 216 divided by 9? Somebody got me? It's 24. So 9 and 24. I need it to be a negative 15. So this one's going to be negative. That works out. Divide by 4. Divide by 4. So this is going to give me a 4c plus 9. And then a c minus 6. Okay, so what am I timesing on the left-hand side? C minus 6. And then on the right-hand side, I'm going to go C plus 1. I'm going to have C minus 6. And then a negative 3C times C is going to give me a negative 3C squared. And negative 3C times 1 is going to give me a negative 3C. All of that's over our 3 terms. Oh my gosh. C minus 6. 4C plus 9. And then C plus 1. That's going to give me negative 3C squared plus 2C minus 6 over C minus 6. 4C plus 9, C plus 1. I want to factor out a negative, so I'm going to just do that right here on the side. I'm going to change all my signs. Oh, I can't remember what they were now. Positive, negative, positive. Okay. Oh, go. No, it doesn't seem right. Positive, negative, positive. There we go. Okay. Woo. I'm going to factor this. 18, negative 2. I don't think... Oh, what works here? Is there any factors of 18 that have a difference of 2? We got 9 and 2, 3 and 6. That's it. So I think you're done at this point. So we probably didn't need to do that. So that should be negative, negative, positive, negative. That.
Yeah, my problem like this, like it's the same but different numbers. Like
There wasn't nothing to simplify at the end?
Yeah, I wasn't sure if I was doing it right.
Sometimes there's not. But you need to check, right? Yeah, I couldn't factor anything out, so. Okay. You guys want me to keep talking and doing this?
Yeah.
Okay. All right. What do I do? What's our, huh? I would copy dot flip, but what else am I going to do when I copy it? I'm going to factor. So what can I factor out of this left-hand side?
5b plus 4.
5, and then d plus 4, and then 5d plus 2. So what can we do immediately in order to get rid of the 5s? That's sweet. Okay, so let's factor both of these real quick. So I got 20 and 9, that's a 5 and a 4. So over here on this bottom, I'm going to have d plus 5, d plus 4. There's already things we can factor, which is awesome. 10, 8, and 2. So d plus 2, d plus 8. I got 4 and a 4 and a 2 and a 2. So I'm left with d plus 8 over. I love those, I'm not going to lie. What am I going to do?
Set the equation for 3 and then negative.
Yep.
3 and negative
6x plus 9 equals 3. And then to do another one, 6x plus 9 equals negative 3. What if it started off as the same, but instead equals a negative 3?
Then you just put it.
I couldn't do it, right? There's no solution.
Oh yeah, because it has to.
Okay, what if it was absolute value of 6x plus 9 equals 0?
No, it's not.
It's just 0.
No,
I can do that.
It's 0.
How many answers am I going to have?
one.
I'm just going to have one answer.
It's 0. You can't do the negative.
Yeah, you can't do a negative 0. Yeah.
Oh,
Yeah.
I remember this.
Okay, so I'm not going to do that one. Okay, rewrite an equivalent expression with denominators that. Okay?
You just factor it.
Yeah, you just factor it and just see which one you're missing so that you can multiply. I don't like this one. So we're going to factor again. But I did have to take a greatest common factor out first. So that's a 7. So I got an 8 and negative 1. So this is 2. And then if you notice in our factor as a D, 2D minus 2, I factored out a D. So it says 2D minus 1 as they're distributing it back into that one specifically. So what I'm trying to say is this and this are the same. Okay?
Do you have to write it a certain way?
We're going to figure out what factors are like missing from each one and then just multiply them. So let's come here. We got 6, negative 7. So that's a negative 6, negative 1. So once again, it's a 2 and then a D minus 1, D minus 6. So the ones that they don't share are the D plus 8 on the one side. So I would need to times this by D plus 8. And then the left-hand side is the D minus 6. So over here, once we distribute that out, we're going to have 6D minus 36. And then on this side, we've got 4D squared plus 32D. I think those are your answers on that one. You don't need to do anything else. Remember, when we distribute this 2 into that one, we're going to get that 2D minus 2. But here's your answers. Okay, I'm going to stop this recording. I've got planning period later. I'll go through the rest and make a second video.
Yeah,